This is a good question. I think it is a good question. Very good question. Try this. Take 5 second time and try this question. Getting any idea, then try this question. I will give you 5 second time. Try this question. Okay, now let us see how we can do. It is given that, see here, it is given, you have to find what it is. You can write like this. It is di by dt. I can write like this. Rate of change of current. By seeing the unit also you can write what it is. Di by dt. Okay, it is given. And I is also given 4 ampere. We have to find the value of VB minus VA. And I have taught you, we have to find the potential difference between 2 points. Then we have to start from A. Yes, I think you got some answer. Okay, let us check it. Okay, start from A and reach B. Okay, start from A. Okay, and reach B. Okay, starting from here, we are moving here. See here, in direction of current only. So negative of 1 minus 1 into a minus sign, because we are moving in direction of current. 1 into current is given as 4. See here, we are moving from positive potential to negative potential. That means minus 12 volt. Okay, now in direction of current only, so minus L, that is 5 into 10 to the power minus 3, 5 L. Okay, L into di by dt. Di by dt is given as 10 to the power minus 3. See here, we can solve it. What we get? Minus 4 into minus 12. We can cancel it here. I think it was plus. Okay, minus 5. We can get here how much? Minus, I think minus 21. Okay, what you got? I think you got some mistake. What you did? I think you have found VA minus VB. Same direction. You remember now? You have to find VB minus VA. Start from A, reach B. Take that sign convention also. Start from A, reach B. Okay? Then we are getting minus 21 volt. Yes, my mistake. Okay. Okay, good. Got it? This type of question are important. You should remember it. Okay? Now, let's move further. If you have any problem in this question, we can discuss it once more, or we will move further. Anyone, any problem in this question? Let us see. Okay. Now, till now we have taken a good question. I think 30 plus solved. Okay, I'll take 5 minutes and show you how to solve any process type of question. Okay. You know that for an infinite wire, you know one thing, the magnetic field is given as mu naught I by 2 pi d. That you know for infinite wire. For circular current, you know magnetic field at center is how much? Mu naught I by 2r. R is the radius. Okay. So suppose we are having one condition like this, x, y, and suppose one wire is given. You just remember one more thing. Suppose we have to find any point here. We have to find the value of magnetic field. It is r distance from here. We can write here B is how much? It is mu naught I by 2 pi r. If we have to find the value of magnetic field here, in the direction of the current only, in the line of current only, okay, anywhere in the line of wire, then here magnetic field always 0 at any of this point. Okay, now if you remember got it, then I show you one concept, one question. Suppose we are having this type of so okay, and it is given like this, and we are pushing like this. Okay, it is telling that find magnetic field at this point. Okay, what we will do for this type of question? Just we will break the current in different segments. We will see here, first segment is this wire, second segment is this semicircular wire, and third segment is this straight wire. Okay, we have to find at this point. It means we have to find, here it is going to infinity. So we know by formula it is mu naught I by 4 pi d into, you remember, sine alpha plus sine beta. This was the formula. If suppose one is here point, that means it is 90 degree. That means it is what? It is 0 degree. 0 degree. It comes to be 0. Then what will occur? It will comes to be sine 0. That means 0 degree. Then it will be sine alpha. And here it is alpha is equal to 90 degree. It will come to 1. We will get mu naught I by 4 pi d. Now see, for this I name it A, B, and D. At this point, we have to find the value of, I say it at this point as M. See, at M, by AB section of wire, see here, these are, to find this at this point magnetic field, what we will do? To find the magnetic field at this point, what we will do? To find at this point, we can do like this, mu naught I by 4 pi, and what will be the value of this? We know this is just radius, so we can write like this, 4 pi and r. And you should take direction of current magnetic field also. You will put your thumb in this direction, AB. You can see your 4 fingers are inside the plane. So we can write this as, for this, you can see here BCD. You can write like this, mu naught I by 2r, and like this theta. Theta is pi by 2 pi. Okay, and it is direction is, if you curl your forefinger in this direction, you can see your thumb is pointing inward. If you curl your forefinger in this direction, your thumb is pointing inward. That is cross here also. Now we look to a third section of wire, that is DE. For D, if you will put our 4 fingers here, we will get magnetic field like this, mu naught I by 4 pi r only, and your thumb will point inside only, that is cross. All 3 are in the same direction, just we will add both 3 of them, we will get our answer. If any one comes in dot, then we will subtract. Okay, got it? You tell me now. You earlier you asked me that this type of question you are facing problem. That's why I explained it. Still you have problem. Any other problem you can ask, because today we are ending our chapter electromagnetic induction, and from tomorrow we will be starting a new chapter, that is alternating current. So D is direction. Okay. Let me tell you. See, D direction. Where is D? D is in this direction. See here. You put your thumb in this direction. D. Put your thumb in this direction. Thumb here. You can find that your 4 fingers are getting inside the plane, this side, and coming out here. You put your 4 finger inside and around this wire. You can see that the thumb is pointing inward the plane. So it is direction is what? Cross. You can see here, cross. Getting or having problem? Still having problem? Getting or still having problem? Please feel free to ask any question. Feel free to ask. Okay, no worry. If you will tell me, I will repeat the question once more. Any problem? Getting set. Okay. Let me take one fresh page. I show you once. I show you in this figure. See what I told you. What I told you. So see. See here. What I told you. If suppose we have this case. Okay. It is A, B, C, D, and E. For AB you got, for D, for BCD you got. Now for D. Okay, let me explain for DE. Now for D and E, for this, you see here for D to E, you can see if you will put your forefinger in this direction, we have to find magnetic field here. Magnitude we can say magnetic field due to D wire, we can say like this. It will be equal to mu naught I by 4 pi. This is the radius only, so we can write 4 pi r. Now we have to find direction. What we will do? We will put our forefinger in this direction. Put your thumb in this direction along this straight wire D. Put your forefinger in this wire along the direction of DE. D to E. Put your forefinger. You will see here going inside here. Put your thumb along the wire DE. You will see that your thumb is pointing inward and coming out. It is getting curved inside and coming out from here. If you will put your thumb in this direction, okay, that means to find the current in this to find the magnetic field in this direction at this point, suppose M, we will write here cross. If suppose we have to find magnetic field in this direction, we will say dot, but we have to find in this point, so it will be cross only. Got it or have any problem? Please tell. Getting or not getting? Okay. By this way, you can solve the question and get your answer. Okay.